From the spectacular views atop Paulina Peak to the lava-butte lava flows that change the course of the Deschutes River, Newberry Volcano is as wondrous as it is intriguing. Located within the Deschutes National Forest in the heart of Central Oregon, the Newberry Volcano is the centerpiece of the Newberry National Volcanic Monument, one of the few national monuments managed by the U.S. Forest Service. Newberry's outstanding volcanic features, recreation opportunities, and unique ecological characteristics led to this special area being designated as a National Volcanic Monument in 1990. The lava flows from this volcano have spread across Central Oregon, covering 1,200 square miles, an area roughly equal to the size of the state of Rhode Island. The city of Bend and the airport at Redmond are built on these expansive flows. Newberry Volcano, part of the Cascade Volcanic Arc, is located just east of the Cascade Volcanic Crest. The Cascades are part of the Pacific Ring of Fire, where several enormous plates are in motion, forming a subduction zone. As the Juan de Fuca plate grinds under the North American plate, heat and pressure from the Earth releases water, which rises to melt the mantle to form magma. The buoyant magma rises to the crust, eventually erupting onto the surface of the Earth, forming a chain of volcanoes.
Newberry Volcano is created by fluids that come off the subduction zone. It's part of the Cascades Arc, but it's being strongly influenced by the extension that's happening right here at this particular location. And so we've got a very large volcano. The lava flows on the volcano typically come out of vents, like cinder cones that are aligned, such as the Northwest Rift Zone. So what you get is the crust is being opened up, and along this opening, you get a series of cinder cones, lava flows come out, and that's a typical thing that happens here at Newberry Volcano.
Newberry is classified as a composite volcano because of its numerous and varied eruptions over time. Newberry is a shield-shaped volcano with gently sloping lava flows that began to build over 400,000 years ago. The many eruptions eventually formed the broadly cone-shaped structure which rises to 7,984 feet at the rim of Newberry caldera. Newberry's volcano summit has collapsed on itself several times during its 400,000-year history. The most recent caldera-forming event occurred about 75,000 years ago and created the bowl-like depression that now holds East and Paulina lakes. A caldera differs from a crater, which is smaller, but can also be formed by explosive materials during an eruption. Caldera-forming collapses occur during highly explosive eruptions when hot ash, lava fragments, and gases rapidly leave the magma chamber. This leaves a sizable void and causes the top of the volcano to collapse. Large volume flows occurred about 70,000 years ago after the caldera collapsed and formed the bedrock beneath the city of Bend and stretching to the airport in Redmond. During Newberry's massive eruptions, lava tubes formed in fluid, low-viscosity, faster-moving lava flows from Newberry's flanks. Lava flowing from an eruption will cool rapidly at the surface, causing it to harden and form a thick crust. This crust insulates the lava below, keeping it hot and fluid. After the volcano stops erupting, the remaining lava drains out or cools, creating a hollow chamber called a lava tube. Over time, thinner sections of tube will collapse, establishing a cave entrance to the tube. One such lava tube is known as Lava River Cave, located within the Newberry National Volcanic Monument. Lava River Cave is the longest continuous lava tube in Oregon that you can walk through. Newberry's eruptions came from hundreds of different vents and formed over 400 cinder cones. These cinder cones and vents were created by magma rising through fissures or cracks in the Earth's surface. A recent example of multiple eruptions along a series of fissures that form several cinder cones is the Northwest Rift Zone, located on the northwest flank of Newberry Volcano.
Underneath Newberry Volcano is a magma chamber, and you can imagine that as the lava is rising to the surface of the Earth, that it is like a garden hose with small pinprick holes in it. And that pressure causes the lava to burst out the sides of those holes, creating a series of eruptions in different locations across this northwest rift zone. So then the lava rises to the surface of the earth and creates several different cinder cones and vents. There are over 400 different cinder cones and vents associated with the magma chamber of Newberry Volcano.
Many of these cinder cones can be seen across the Central Oregon landscape. The easiest one to visit on the monument, Lava Butte, is part of the Northwest Rift Zone and was created about 7,000 years ago. The most recent eruption of Newberry Volcano was about 1,300 years ago. The explosive eruption produced ash and pumice that was carried by the wind and deposited as far away as Idaho. The same eruption also formed the big obsidian flow within the caldera. Obsidian is black volcanic glass, shiny in appearance. It forms from magmas with very high silica content. Cinder cones and vents of Newberry scattered throughout Central Oregon make up the volcanic landscape seen and enjoyed today. These eruptive episodes not only created new volcanic features and changed the topography of the landscape, but also affected many aspects of the ecosystem. Lava flows temporarily dammed the Deschutes River, which forced the river into new channels. Ash and porous lava rock from both Newberry and other nearby volcanoes have changed soil structure, which in turn altered plant composition across the landscape, favoring plants that can survive and thrive in sandy soils. The most significant of nearby eruptions was Mount Mazama, which formed Crater Lake and deposited over 2 feet of ash across the area that is now Newberry National Volcanic Monument. Rugged lava flows create a natural corridor, routing migrating wildlife around rock formations that are difficult to cross. Migration corridors intersect with the corridor that Highway 97 passes through. Both humans and animals have traveled these passages for thousands of years. Modern uses of the corridors create greater potential for conflicts between people and wildlife. Innovative means to reduce these conflicts have proven successful on Newberry National Volcanic Monument.
Animals like to follow natural features across the landscape. So when the lava intersects that, they use the edge of the lava as one of those areas they utilize the most. We recently put in 2 underpasses that go across Highway 97 for primarily deer migration. And so in order to get the deer to use those crossings efficiently and effectively, a fence had to be put in so that it funnels them to those crossings. With the pictures that we've been getting, not only deer, but everything from ravens to mice to humans use those crossings. The one main species that uses lava as habitat is the pika. It's a rabbit-like animal that uses those cracks and crevices in the rock, and they forage on the vegetation.
While people and animals skirt piles of volcanic rock and continue to live upon the lava flows, it's easy to forget that Newberry is still an active volcano. Recent eruptions like the one 1,300 years ago that created the big obsidian flow, as well as the presence of geothermal activity including hot springs and the frequency of small earthquakes on Newberry Volcano, are all indicators that Newberry is likely to erupt again. Additionally, Newberry's magma chamber lies just a couple of miles beneath East and Paulina Lakes. The current magma chamber, shown here in red, has been mapped by Emily Hooft, a geologist at the University of Oregon. The blue bodies represent older magma that stalled in the crust instead of erupting, and have now cooled and solidified. These images help scientists construct what is essentially the magma plumbing system beneath a volcano, which gives us a better understanding of the depths that magma is stored in the Earth's crust before erupting. The location and volume of magma is useful for scientists. The known presence of this magma chamber indicates that an eruption will happen in the future.
Volcanoes do generate little earthquakes as magma moves up through the volcano. That movement of magma causes the rock to break. As the magma is forced its way up, it opens up little fractures or breaks in the rock, and each one of those little breaks is an earthquake. But generally you don't feel those earthquakes. They're usually fairly small, in the range of like a magnitude 2. It can be a little bit bigger, But normally, volcanic earthquakes are not something that people feel.
Well, back in the summer of 2011, the USGS installed a network of 8 stations around Newberry in the volcano monument. Each of those stations has a seismometer and a GPS instrument. So there's actually a pretty good network of about a dozen or so seismic stations that are recording seismic signals and GPS stations that are recording deformation of the Earth.
Newberry is a potentially active volcano, and it is very likely that it will erupt again in the future. It can erupt in a variety of ways. If we look at some of the most recent eruptions at Newberry, the most recent was the Big Obsidian Flow about 1,300 years ago. So that eruption would have created a large plume of ash and gas that would have blasted up into the atmosphere, and then later kind of a more oozing lava flow, which is what we see at the Big Obsidian Flow.
Newberry Volcano offers scientists exciting opportunities for research in geothermal energy production. Current exploratory projects outside the monument boundary, but still on Newberry Volcano, are showing some promising results.
Geothermal energy takes the heat from underground in the earth, so you can work on a volcanic system or other kind of heat traps that are below the ground. And we take that heat and we generate steam from it, and we use that steam to drive a power plant. Since the 1970s, there's been exploration by geothermal companies out here looking for an existing steam system. So a conventional geothermal system has steam underground from that hot rock with water naturally moving through it, so that generates natural steam. What we've done, Ultra-Rock Energy, we work with EGS, it's enhanced or engineered geothermal systems. We have the technology to go in where we know there's hot rock, we can drill a deep well, and the wells we work on are about 10,000 feet deep. And we pump in water and we create a fracture network filled with water. It's just clean groundwater that we use, so no chemicals or anything. And we take that water, we let the rock heat it up, we create steam that way, and then we can bring it back to the surface and drive a power plant.
Though all the research and monitoring of underground activity is exciting, the above-ground beauty and intrigue of Newberry inspired individuals to lobby for its protection over the last century. Designated in 1990, Newberry National Volcanic Monument was established for its wide variety of volcanic features, including cinder cones, lava tubes, obsidian flows, and more. Newberry contains a wider variety of features within its boundaries than other national parks or monuments in the U.S. Visitors are encouraged to learn more about Newberry National Volcanic Monument by visiting one of 2 visitor centers. Accessible and exciting for visitors of all ages, you don't have to be a geologist to appreciate this magnificent landscape. We invite you to explore the complex ecosystems, rich history, and the many transformations of this surprising and spectacular national monument.